My name is John O'Keefe. I've been here many times before, and I hope to be coming here many times in the future to tell you about VA Smalltalk. So today I'm going to be talking, if I turn this on, I'm going to be talking about our update.
I think you don't have selected the presentation, that's why it's not working. Could be that.
Well, it's not working here either.
So,
Forget that.
I don't know.
Yeah. I know how to do it.
Take your time.
Oh, it's definitely not. Oh, there we go.
That was the problem.
There we go.
Yeah.
Ah. And so now, cool. Okay, so I'm going to talk just a little bit about our company and what we're doing. I'm going to talk about the release content for our current 2016 release. I'm going to talk mostly about the next release content, and then we'll have questions and answers. So for the company, VA Smalltalk remains strong, and we are developing new technologies, and we're acquiring new users of the product. In our technology development, we have a new release that's coming out very shortly, and we're working on our 32-bit, 64-bit VM, which would be a total replacement for our existing VM. We come to conferences. I've been here for many years. Seth Berman, our Vice President of Engineering, is here, and this is probably his second or third Smalltalks conference. We go to ESUG. We sponsor the Camp Smalltalk in Marquette, Michigan, that was held in September, and we are hosting a Camp Smalltalk in North Carolina at the end of March next year. That's probably a little far for most of you to come, so but if you happen to be in North Carolina at that time, we'd be more than happy to see you and have you participate in this 3-day event.
What city?
What city? It's in Durham, North Carolina. So we talk about the Raleigh Camp Smalltalk because more people seem to know about Raleigh than Durham. But I live in Durham, and the Camp Smalltalk will be in Durham. We have a very nice facility and with some hotels that are very close, and we hope that it's going to be a lot of fun for those who are there, as well as a learning experience. So for our current release, our focus has been on a number of items, enhancing our cryptography support, adding IPv6 support, improving our installer, re-engineering almost completely our build system, and the new VM. So as I say, this is going to be available fourth quarter, which we're in, so you can imagine that it will be very soon. In terms of base class libraries, we've done some work on ZipUnzip. We are adding support to the image to make using 64-bit data easier. This is useful in 32-bit as well as 64-bit VM environments, but it's definitely needed for 64-bit. And we do transparent adaptation to the resizing of long data on the various platforms, and transparent platform adaptation. A long isn't the same size on Windows as it is on other platforms. So we do have to dynamically adapt those long fields. For IPv6, we're probably all at least a little familiar with the idea that IPv4 is out of address space. All the IPv4 addresses have been given out. So IPv6 has become very important. And for the next release, we've enabled all layers of our product for IPv6. That's the low-level socket communication interface, the server support, and the parts layer, which is where you can construct your application from reusable components. The UI has been adapted to handle both IPv4 and v6 addressing syntax. Essentially, it's a free-form field now. And we have set up some preferences so that you can say whether you want v6 to be preferred or you want v4 to be preferred when you're communicating across the network. We have supported Seaside in Greece for quite some time. We were already at the 3.2 level of Seaside in our last release, and so the only things that we've done is a few small concurrency updates, and we've adapted it for IPv6, which was some very minor changes. Cryptography is an really important thing in this world today, and we have worked very hard on it. Seth is going to give a presentation tomorrow on our cryptography support, so I'm not going to spend really any time on it here. Suffice it to say that we are supporting OpenSSL 1.1, which is the latest version of OpenSSL. And we have backward support for lower levels of OpenSSL, so that there's no breakage to those users who are already using our OpenSSL support. We've got secure memory support, so it's kind of important that if you have secure items that nobody's supposed to see in memory, then nobody should be able to see them in memory. So you don't want to have the unencrypted or undecoded bytes laying around just anywhere. And with both Windows and Unix, we use system facilities to guard that data so that it's not visible outside the program. And on Linux and our other Unix systems, Sun and AIX, it also won't show up in a core dump. It'll be hidden. We've made some minor changes to our SQLite support to bring it up to the latest level, and this is mainly performance improvements, but a few bug fixes. For when we install the product, we have a launcher called Environments, and we've added some pop-up capability there that'll let you open file explorers on various places. The installation folder of VA Smalltalk if you want to see what got installed, and also open a command window in the selected environment's location so that you can manipulate the data associated with that environment. And the last thing here is that we now support duplicating an environment, and that means that if you create an environment and you want to change its name, for example, then you can do that simply by duplicating it with a new name. That was a really strong request from several of our customers. In terms of installers, all our Unix installers are now headless, which means that you can install them on a server that has no X support. And in addition, we've made the Windows installer so that it can be scripted, so that you can run unattended installations of Windows. We support new platforms, the latest versions of Ubuntu, Fedora, and Red Hat Enterprise Linux. We've validated on those 3 new platforms. So I want to talk just a little bit about our build system and why we re-engineered it, and why anyone should care but us. Because the build system is something that we use internally to create our images, create our product distributions. So our old image build and installation build was all custom Smalltalk code. It's old, dates to the mid-90s, and the code quality wasn't the best. It was very difficult to, you might say it was a big ball of mud. And we've been dealing with it because this is something that doesn't really show on the outside to our customers, but the builds were slow, they required significant manual intervention, the Windows and Unix builds had to be done in sequence, not in parallel, and we didn't manage the installation artifacts, which means in some cases the builds weren't repeatable. In our new image build, we're using CMake to drive it, to script the builds. We can restart at any job step. We can duplicate, and we've removed the duplicate and redundant processes. As we went through the code, we saw there was a lot of code that used to be used but wasn't anymore. So dead code removal. We still use Smalltalk where it's appropriate, and that's driven using our scripting interface. So we have the ability to do fully automated nightly builds now of our product, and the output of the builds will be captured in a Git repository so that we can compare from build to build and understand what's changed. So as I said, the old installation, now I'm not talking about the product build, but I'm talking about the code that's used to install VA Smalltalk on your machine, was also a Smalltalk packaged image. Same ball of mud code. It was slow. It did file-by-file copying, and it had to ship the file attributes in separate side files. So it doubled the number of files that were in the installation zip. The new installation uses standard installers on all platforms, MSI on Windows, RPM Deb on Linux, and PKG on Solaris. We've removed the documentation to a separate package so that if you don't want locally installed documentation, you don't need it, which means we've got smaller download packages, and the install is lightning fast. So then, what about testing? I mean, here is where our build system really shows through to our customers, because we want our customers to get the very best tested code, very best quality code that we can. And in our old system, only the VM build had automated test cases. Every time we built a VM, we ran a suite of test cases. We now have the ability to run image tests. So we have both installation verification tests, verifying that we install properly. We have the VM tests that we had before, and we have image tests to test an ever-increasing portion of the code in our image. And the nice thing here is all platforms can be tested in parallel. It just depends on the machines we have available. We currently have over 10,000 mainline test cases and growing. And besides that, there's test cases for many of the features that are separately loadable and have not been automated at this point. So that's what you're going to get if you get a VA Smalltalk this year. But what's in the future is more interesting. Next year, based on input from a number of different sources, this is what we're looking at. We're going to continue to support Seaside. We'll improve it as Seaside improves. That will be ported. We hope to fix the long-standing issue with continuation support in the new VM. For middleware, we're looking at Postgres, and we're looking at some kind of NoSQL support, be it Voyage Mongo or React or Cassandra or something else. We'll have somebody assigned to do the evaluation and decide on that. We continue to work on the GUI look and feel. We would like to replace our motif support on Linux with GDK. We don't know right now if we have enough resources to do that for the next release, but we will be evaluating that. In terms of communication, we've been asked to support HTTP2, which allows you to push content out to the web browsers, and 0MQ, which is a very lightweight TCP-like communication between systems. And in terms of servers, we are looking at easy-to-use server farm support. We have server farm support. We've always had server farm support since 1994. Many people don't know about it because it's not that easy to use. But some of our customers have invested in quite heavily in using this support. And we want to get it out to more customers, so we're going to try and make it easier to use. In terms of development tools, we are currently already working on improved code library access over wide area networks, our revamped code changes browser, and a code merge engine. And in terms of performance and scalability, we're looking at incremental garbage collection and, of course, 64-bit Smalltalk, which is going to be the big item in the next release. So we call this project Dino, and this is Dino 2. So you can imagine there was a Dino 1 that never really came to fruition. So the project goal is to have 64-bit VMs for x86, PowerPC, and SPARC. We'll have 32-bit VM with performance at least as good as the current production VMs. And we have an improved build system and test system for our VMs. Now, just to review our current VM is built from a proprietary Smalltalk model. So if you're familiar with Slang, which builds from a Smalltalk description of a VM into C code, which is compiled to create the VM, we have a Smalltalk model that describes the VM in a kind of lower level. It actually deals in specific machine capabilities, and that then generates assembler code for the specific machine that we're running on. So the VM interpreter, the JIT, and the primitives, for the most part, are generated assembler code. We have some supporting modules written in C, 135,000 lines of assembler, mostly generated, and 50,000 lines of C. We have a new infrastructure where we have a common build system across all platforms based on CMake, GCC, MinGW, and MSVC compilers. We're building a single source 32 64-bit virtual machine. It's running on Windows and Linux now. Our current focus is performance improvement. We are going to be shipping 64-bit images, but we can auto-convert a 32-bit image to a 64-bit image when it's loaded. So you start up Smalltalk on a 32-bit image in a 64-bit environment, and we'll convert it on the fly. So Dino 2, it's interesting, it's gone through really 3 phases. The first one was Raptor, one of our Dinos. This was our first generation C interpreter. It was slow, but it was 64-bit clean. It didn't use any special facilities to adapt for building interpreters. And we achieved 80% bytecode speed at on 32-bit byte codes, but only 50% message send speed. So you can see it was really not acceptable. But it taught us a lot about how to do what we were doing, and allowed us to move forward with the image work because we took our current VM and we shimmed the new code in primitive by primitive, module by module. So we always had a running VM through the course of building Raptor using this shim code. And this ended up with 90,000 lines of C code, including the primitives. So after we felt comfortable that we had a little better idea what we were doing, we switched to Indominus Rex, our second dinosaur. Gosh, maybe a dinosaur wasn't the best sort of thing to use as a logo for this, but it's what we got. So this is our second generation C interpreter. We've speeded up the C code using many of the optimization facilities of GCC. We've achieved now 85% bytecode speed on 32-bit and 75% message send speed. So the message send speed went up by 50%, the bytecode processing a little less. And this is, well, in this environment, the primitive implementations are often faster than production because we don't have to do as much calling back and forth between assembler and C, and the call overhead in an interpreted environment is always very high. So you want to do as few calls as possible. We discovered that we have a stable implementation, and this is actually our reference platform implementation. So we always will continue to do development on this version of the VM because it's easier to debug on than the next version, and it's all in C. We discovered that small changes to this huge interpreter loop that we have result in unpredictable behavior. The GCC compiler sometimes goes crazy when we just change a few things. Also, we continue to have register allocation problems. We don't have as many registers available to us as the production VM did because C consumes one register. So we're on x86, 32-bit, we're always at least one register short. And we were in a constant fight, and we're still in a constant fight with the compiler over what should be going on. But in this version, we're down to 85,000 lines of C code, so it's a little smaller. And as I say, this implementation of the VM will continue forward in parallel with Coelho, our third dinosaur. So for Coelho, we're using LLVM to code gen the interpreter. So this is a compiler toolkit, and it uses an SSA abstract assembly representation, but we're still down one register from the production VM, which makes it difficult to achieve the same level of performance on 32-bit VMs. We can't use the hardware stack register, but the superior code gen that we get from LLVM now makes up for part of that missing capability. So on 32-bit, we're at 100% bytecode interpretation speed and 110% message send speed compared to our current VM. So we're happy with 32-bit. We've achieved our goal. We achieved at least 20% improvement in primitives going to this approach. And for many prims, the performance is much higher, 4 to 6 times for floats compared to the current VM. So at this point, we're at 19,000 lines of C++ code, which is code gen from LLVM, and 75,000 lines of C code. And this will be the VM that will be shipping. Oh, it doesn't say anything on here about 64-bit. Maybe you saw that, made notice of that. We are focused on the 64-bit now. We are about 5% performance below the current 32-bit VM, but the performance has been on an upward slope as we go through the creation of this VM. So we're confident that we can get the performance above the current production VM's performance and open up huge amounts of memory for the object store. We started in July of this year our early customer involvement program. This is like a pre-beta. We took a very selected small set of customers and gave them the code so that we can get early feedback from customers who had a critical need for 64-bit. And we are getting good feedback from these customers and feeding it back into the development of the VM and the image. We will be having a beta program early next year, and we'll be shipping the production VM 32 and 64-bit later in the year. So how do you get VA Smalltalk? Anyone can download an evaluation copy, and once you've downloaded it, it runs forever. You don't have to get a new version unless you want to upgrade to a new version of the product. You could buy a developer's license. We like people who buy developer's licenses because that keeps us gainfully employed in improving the product. But not everybody can afford a developer's license. This product comes from an environment of enterprise customers. We have very large customers with 200, 300, 400 developers, and that's the primary area of our customer installations. Although we have some very small customers too. It's used by a chimney sweep company in Germany. So you'll be able to download development builds. These are our weekly builds. You can be a committer on an open source project. It doesn't have to be one of ours. This is any open source project. Or you can work for or be a student at an educational institution. You can get a free paid-up license for VA Smalltalk for, yes, all the students for working on a project that you're working on. And I appreciate you investigating and evaluating our product. I don't know whether it could have done what you needed it to do, but thank you for at least evaluating it. So, this is our contact information. When in doubt, send an email to me, John_O'Keefe at instantiations.com, and I'll get it to the right place. So, questions?
We have an Instagram, we work with British, And we have an application that runs in Linux or Red Hat. And we have to connect to Argenta 64 bits database. So our problem was that this range at the end is 32 bits, so the connection to the Argenta, we have to make it via RPC connection.
Yes.
So with the 64 bits at the end, I understand that we will be able to log into Shenton via link. That is much faster. No?
I will defer to the GemTalk expert in the room.
You will be able to do it, but we should talk about it.
Yeah. So you're right that with the 32-bit VM, you cannot connect to 64-bit DLLs on any of the platforms, and that actually was more of a driving force to us doing the 64-bit VM than the expansion of storage, because products are starting to ship without 32-bit DLLs.
Yes, I have two questions. You said that now you have 10,000 bits for the image loader. How long does it take to run them? And the second question is, with the new VM, will you be able to use the same images as now, or will you have to create new images?
So, the first question was, how long does it take us to run the 10,000? A couple hours. Oh, faster than that. Yeah. So, it's different on Windows, where we have kind of newer, faster machines. Our PowerPC and Sunbox are kind of old. And the second question, can you use the same image? You can take your current 32-bit image from VA Smalltalk 862. I'm just double checking. And it will load on a 64-bit environment. It will be automatically converted to a 64-bit image. So if you save it, it'll be a 64-bit image. That 64-bit image cannot be converted back to 32-bit. Once you've done it, that image is 64-bit. But it has to be a reasonably current version of VA Smalltalk that you're coming from, because there is support code in the image to allow it to reside in a 64-bit environment. Other questions?
Okay, thank you very much.
Thank you very much.
About 10 minutes per